Welcome to the lecture on machine learning versus deep learning by Python Labs. From a long time, people have dreamt of creating machines that can think. Today, artificial intelligence (AI) is a thriving field with many applications like medical diagnosis, speech recognition, image recognition, etc. And that's amazing to know that these advanced models have achieved human level accuracy scores. So, what you can say is today, these advanced algorithms, these advanced models can recognize your speech just like a human does. Now let's see a Venn diagram that shows the relationship between machine learning and deep learning. Okay, so first let's write out the equation that tells about their relationship. Okay, so AI here is the superset of machine learning, and machine learning is the superset of your deep learning. Okay. So as we can see that they are interdependent, and this machine learning is an approach of AI, an approach for artificial intelligence. And just like this, we have another approach that knowledge based systems or the expert systems. Okay, here's an example, the expert system. So why are they called as knowledge based systems? Because uh, they have hard coded knowledge, knowledge about the world in formal language. Okay, so now let's see the subset of AI. So that's what your machine learning. Okay, now let's move on to machine learning. So first thing that how machines can learn. So the classic machine learning algorithms learn by mapping features to output. Okay, so first let's see what are the features or representations. Features or representations. Okay, so features or representations. Okay, so just let's see a case. Okay, where we have three shapes: a square, circle, and a triangle. Okay. Now what we want is to create a classifier. We want our machine to be able to classify these shapes. If we input an image of a triangle, so it should return that it's a triangle. Okay. So how can we differentiate between these shapes? First, let's think about it. So what we got is our data, the first thing, and second thing is let's find out the features that differentiates these shapes or the input. Okay, so how can we differentiate them? Okay, so one way is by looking the corners. So what we did is we took a feature which is number of corners. Okay, by looking at number of corners. Okay, so and the third thing is specifying a model which will look at the shape. Okay, if that see your corners equals 3, so return triangle. Okay, now what if we provide it with a 3D input, a 3D shape as an input, like example a cuboid, a front faced cuboid. So we know that this is a cuboid, this is a cuboid, but what our this model will look at as that it is having four corners. Okay, so that means this should be a square. Yes. Okay. So what we have to do is we have to look for a new feature that can differentiate between 2D and 3D. So this feature designing, feature engineering is a lot difficult task to do. Okay. So one other thing we can do is, what if a model can find out the features on its own? What if it can learn the representations on its own? Okay, so that's representation learning. Our model learns these features on its own and then classifies the object. Okay, now if I provide it with 2D, 3D, and like a multidimensional shapes, and I train my model on it. Okay, so what it will do is it will automatically extract the features that can differentiate these shapes. Okay, so that's what your deep learning is, and here is an example. What is a multi-layer perceptron? Multi-layer perceptron. Okay, now let's differentiate classic machine learning algorithms with deep learning. So the first thing through which we can differentiate them is by which kind of problems do they solve. The classic machine learning solves the problems which are intellectually difficult for humans but easy for computers. They are the problems. Those can be described formally by using mathematical rules. Example, converting centigrade to Fahrenheit. We have the instructions, we have the formula how to compute it. Okay, now one more example is to find the relationship between area and the price of the house. Yes, we can compute it by using different models. Okay, so what happens in deep learning then? Okay, deep learning faces the real challenge and tries to solve the problems that are intellectually easy for people to perform but hard to describe formally. Okay, like recognizing faces and spoken words. These are those problems that a person can't describe. How are they doing it? Okay, so deep learning does that magic. We don't have to describe that specific thing. So, example, we can't describe all the features of a face. We can't hard code the features of the face. We can hard code the representation of a face because there are too many representations, too many features in an image. So, what a deep learning model like a CNN model does is it, layer by layer, it breaks down that complex representation into simpler representations. Okay, we will talk about it while discussing our CNN models a lot. The next difference to consider is in classic machine learning algorithms, feature learning is very important, whereas deep learning works on representation learning and finds representations on its own while training.